Everybody, how's it going? Good, good. Give yourself a round of applause for hanging in there so long, like listening to data. All right, it's really cool. So I just want to share for a few minutes that I'm a big fan of The Prophet with Marcus Lemonis. Anybody a fan of Marcus Lemonis, The Prophet TV show? He just last week there was an episode where he was helping a small business where they would like buy vintage clothing and then embellish it with other stuff on it, like patches and pins and other parts of clothing, and make really unique clothes. And then try to sell it they'd buy it for like $35 and sell it for like $635. And what they did was they would actually go to the vintage store, go shopping, and then go find all of the other parts, and then assemble it themselves. And they were making like really cool looking clothes. And he came and he said, well, what you're doing is amazing, but it's not scalable, right? So in order to be scalable, you need to have some kind of supply chain management. So you need somehow of sourcing that clothing, having some kind of operation. You need to plan what you're trying to do. You need to figure out, are you going to build it yourself? Are you going to buy it from other people? Are you going to outsource the construction of it? How are you going to manage the quality of the construction? Right? All of these things are very, very traditional supply chain management, right? So planning, sourcing, constructing, figuring out how to deliver it to your customers, and then figure out also how are your customers actually going to consume it. Are you going to sell it online? Are you going to sell it in the store? Are you going to sell it door to door? Right? And all of these different things, all these different parts of supply chain need to be really thought through before you take action, especially if you're trying to scale. If you're a small little shop and you just enjoy doing it for fun, and when it's done, and there's no pressure, then that's a different thing. But if you're trying to be competitive, you need to have a very repeatable, scalable process that could be run pretty much with lights out operation. So what I did is I took that concept as a metaphor and I applied it to data. So that's what we're going to talk about for the next few minutes. So we're going to take traditional supply chain and take those 5 steps and think about when we're doing alternative data analytics, there's a few things you need to think about. So one thing is really understanding and defining what is the problem that we're trying to solve, right? That's step number 1. And then think about how we're going to solve it. And if we do solve it, what's the so what to your organization? Like what are you going to get out of it? How do you prove that it's successful or not successful, right? And you have to define that and quantify that, and then prove whether it's actually worth doing, right? They're really great ideas that even if you get them to work, they're really not worth doing, right? And then if you start doing it and it's taking longer or it's more expensive to do than you originally thought, when do you draw the line? When does it become a diminishing return, right? So all of this should be defined before you actually start. One more thing I should talk about here is also aligning resources. One of the biggest challenges in alternative data today is finding people who can actually do it, right? Data science is one thing, but doing the data engineering that's required to do the science first is probably one of the toughest challenges that I've seen throughout our clients. And we're based in New York City. Financial services sector is our number 1 vertical in our in our business. And it's across the board, whether you're a big bank or a small hedge fund and everything in between. Finding really good data engineers who could acquire the data, prepare the data, quality assure the data, that is something that is a challenge. So make sure that you have the resources before you invest much in anything else. Once you have your sources, figure out where you're going to get it, figure out how you're going to manage it once you get it, how you're going to do things like detect changes. If you're receiving files every day, are you receiving the same files and processing the same data? So doing change data capture, all of those types of methods need to be thought through. And then validating your data. Once you receive your data, is it whole? Is it real? Is it good, right? So understanding what are the business rules that you need to know, getting this data in, and then figuring out how to systematically test those rules as it comes in, right? One of the biggest challenges with sourcing data is most alternative data is not fully structured. It's usually semi-structured, and the schema of the data sets change without you knowing it, right? So the first time if you're receiving it once and doing analytics, that's fine. But if you want to receive them in a recurring fashion, they could change the schema on you and you wouldn't know it, and then all of your processes break, right? That's called schema drift. That's become a very common thing with the alternative data world. So you have to know that when you're receiving this data, you need to be able to test the schema and react to it systematically and detect change and be able to still process all of that data. Once you receive the data and you know that it's good, then you have to figure out how to lay it out, right? This typically involves some sort of object data store or data lake where it could be, we're talking about satellite images, it could be PDFs, right? Some of our clients are in the buying mortgage business, so they just receive, hundreds of thousands of PDFs of mortgages. So we need to be able to have some place to put them. We put them in an object data store, usually on the cloud, doesn't need to be. And then, we have to have some processes in place where we can do some OCR in these PDFs, or we can have some computer vision where we're reading images. We were talking about the satellite images, counting cars, things like that. What is the tool sets that we need in order to build these pipelines to convert this raw data into usable, digestible data for science to do the analytics? And then we need to be able to divide and conquer, and this is usually something that's probably the most ambiguous part, is where we're doing data engineering, where we're preparing the data, making it clean, conform, consolidated, usable, prepared for data scientists who will then start engineering the features to feed the models, right? And that's typically where we do the divide. Data engineers do the data preparation engineering, and data scientists do the feature engineering. And that pipeline should be seamless. And then everything that we create then becomes an asset to your organization. And it should be stored pretty much for perpetuity until you decide to archive it, right? So you need to have something that's incredibly scalable. And not only scalable, but elastically scalable, right? It should not be an infrastructure project to store new data, right? We just need to have a place where we can store it, and as we grow, the platform grows. Now we have the data, now we have to figure out how are the users, how this either scientists or portfolio managers or whoever needs to make decisions based on this data, how do they want to experience this data? Should it be through APIs to other applications? Should it be through microservices? Should we have a data as a service, self-service environment? Should we have a data catalog? Should we have all of these things? Should we have a typical BI dashboard where we can just visualize, have a visualization tool? Typically, we want to give them the ability to have a workplace, right, where they can spin up their own environment in a very safe place. We talked about governance all day today, right? Governing this data, having it very secure, where you have to apply for data through some kind of review board to be able to access this data, get this data, and then keep it isolated, right? Almost like in an isolation chamber, until you decide whether this data has value or not, right? So very quickly, unstructured data, without worrying about like rigorous data modeling, ETL, like all of that stuff, just be able to ingest it and start exploring it right away. We want to be able to do that in a very controlled data laboratory, something where we use the new paradigm of infrastructure as code, where we can just like trigger some code, it's going to open an environment for us, we can hit it with Python, with R, with whatever we want, right? SQL, and be able to just interrogate this data. And then once we decide this data does have some value for the business, then we can go through a data governance lifecycle to get it promoted to be productionalized. That's the process. So, and then the users, now that we have this data and we have some insights, what do we do with it, right? One thing is we want to see, do we need to make this actually recurring or is it a one-off? And do we want to go through this data governance lifecycle in order to make it public to either internal users or to even external users if you're in the business of selling data, right? If you're trying to monetize your data, then you need to have a whole different set of data governance requirements. We talked about sanitizing data, anonymizing data. You know, being able to architect a solution where you can have the same data set, where if I have the privilege to see the data, I will go through and see that data set and see all the values. If I don't have access to see all of the details of the data, I will hit that same data set, but it'll be anonymized, right? And figuring out how to architect that solution. Does it sit in the same place and is a semantic hiding it? Is it two separate data sets and the semantic makes it look like one? Like really understanding what are the requirements and how to architect it so it can scale and be safe and pass through regulatory requirements, right? That's something that we really need to work with. The business, your your compliance officer to make sure that no one gets in trouble and everyone stays safe. So this is essentially what it looks like. So we break this up into 5 pieces. And this is the architectural diagram for an alternative data supply chain. So first thing we want to do is we want to do our planning. We want to ideate with the business, right? Be able to figure out what it is we're trying to accomplish, estimate the value of what we're trying to do, set goals with measurable KPIs. We want to define the deliverables, align the teams, create a schedule of what we're doing, and then assess the risk if we don't do it, right? Communicate a plan and then measure success. Once we do that, now we're ready to be able to figure out what are the sources that we need. Are we doing integration with our Geneva data, with our InvestTrans data, you know, getting data from companies like Quandl and 1010 Data and Eagle Alpha, right? All of these alternative data sets, or are we rolling our own, right? I'll share one of our success stories where, you know, we talked about earlier getting pricing data off of websites, right? So this is something you can buy it or you can build it, and there's pros and cons of both. The key is to have an environment like this where you can ingest it and have a pipeline where you can quality assure it and make it safe to be consumed by your internal folks to get insights out of it. If we look in the middle where it says construct, we have a few things, right? So one thing is we want to be able to ingest this data, no holds barred. However, that if it's JSON files, if it's images, if it's PDFs, like we don't care. We need to be able to ingest it and keep it, right? We want to be able to say at any point in time, what did that data look like on that day? And we need to be able to create a report that we've ever created over history. And then you'll see in the data lake, there's 2 tiers. The first tier is the data pretty much in its raw state, but it's put in a consumable format, usually a Parquet file, but it's something that gives it some kind of structure, and it also, so it makes it queryable. So you could put a data discovery tool on top of it, like Trifacta or whatever, and be able to explore this data and be able to assess, is this data even what I want? Is it what I need? You know, acquiring this, we talked about, you know, alternative data vendors, figuring out which is the right data set. There's multiple vendors who have kind of the same data. So being able to experiment with the different data sets very quickly and very efficiently is very important, right? So we want to be able to have a laboratory environment where we can like spin something up very fast, look at the data, and then assess its value right away. Once we do that, then now we want to start engineering that data so it can be used within the organization. So now we're doing data integration. We're doing things like identity management. So if you have, you know, an IBM ticker coming from 10 different sources, it's probably displayed like 4 different ways. So we need to be able to write some algorithms, very simple stuff, but basically we want to do some matching to make sure that we understand what IBM is across all these different sources so that we can match it all up. The other thing that we want to usually do is do some date math to figure out what's happening when, right? Because we want to see what's impacting other parts, right? Other different types of data. And we need to have everything sequential. So stitching things together chronologically is very important. And that's something that typically a data scientist doesn't want to do, right? A data scientist wants to be able to have its data chronological order. Here's everything that I need in the order that it happened. Now I could build some models, and now I could do something interesting. Now I could start really engineering some features about this data, right, and figure out what has statistical significance and what doesn't. So that all happens in the second tier of the data lake. The data science ephemeral workspace, that's the other space where we want to be able to spin something up in a very safe environment. If you think of real science, where you're a scientist like creating drugs or something, the first thing you need to do is you need to have a completely clean room, and then bring in new chemicals and new species and new bacteria, new tumor samples, whatever it is you're doing, so that nothing gets defective, right? And in data, it's very, very similar. We want to have a complete clean space. We want to bring in new data sets that is not infected by any other data sets, so that we can, and hasn't been, already tried to be manipulated by IT that we don't know about, or some other system that we don't know about. We want to see it in almost its purest state, right? And then we want to just apply some metadata to it as we learn more things about it. That metadata will eventually become part of the business rules for processing that data on a recurring basis. The typical tools that we use, we'll talk about tools on specific clouds. I was happy to hear, pretty much everyone all day was saying that the future state of alternative data ecosystems is on the cloud. In my experience, 100% of our clients doing alternative data analytics is on the cloud. And usually part of what we're doing is getting them to the cloud. And then we want to have an environment where, usually they're writing Python and Jupyter notebooks, or doing some BI and tools like Looker or Tableau or Qlik or something like that. On the bottom right-hand corner, you'll see a thing called CCAN. There's actually a few folks here that I've already done this for. But CCAN is an open source Python-based data catalog. Usually, most of the data catalogs that I've seen on the market today, commercially available, do not serve the whole purpose do not satisfy all of the needs of what we need in order to make an internal or even outward-facing data marketplace for your alternative data. Right? In order to do that, there's a lot of customization that needs to be done. CCAN, I have nothing to sell, no products. It's open source. You can go download it and use it today. If anybody goes to any data.gov of any country in the world, it's probably being generated. That whole experience is CCAN. Right? If you want to be able to find data, explore data, purchase data, CCAN is actually a really nice interface to do it with. A lot of our clients are using that internally now. Now that you're creating new data sets, ingesting new data sets, creating new insight, having a data catalog to be able to find this stuff and look at it to make sure it's what you want is something that is not optional. It's really mandatory. It's absolutely required. If you're moving to the cloud, just take a picture of this. I won't go through it. If anybody wants it, you can email me, joe@caserta.com. But what this does, the cloud could be pretty overwhelming. Like each one of the cloud providers has hundreds of different components. In order to do a full data ecosystem for alternative data, you really need these dozen things. Right? If you know these dozen things, you're going to be able to build it. It's what you do with these things, right? After you have it, how do you architect it? How do you configure it? That's the stuff that you need some expertise to do. And then once you do that, now you need to be able to automate it. So create an entire data framework so that every time you bring in a new data set, you're not recreating the wheel, right? You have a framework to work within so you can do data quality assurance. You could have a dynamic rules engine. You can make sure that it's complete. You can do integration with your internal systems, right? All of this should be done so you can very easily, quickly ingest your data. Embed data cleansing and data integration. Automate, automate, automate as much as you possibly can. And build an AI environment that will learn as you experience more data so that you can do more automation without coding everything yourself. Go agile, leverage consultants. It's always better to have somebody who's been there, done that at least once, so you're not learning on the job, which is a very, very expensive way to go. And just remember, innovations may fail, but companies that don't innovate will fail. And just, if I have another minute or two, I just want to go over some lessons learned. It's just take 30 seconds. So alternative data, 80% of it is exploration, and 80% of it, quite frankly, may lead to nothing. And you just have to know that going in, right? You have to know that, you know, of all of the data that you explore for opportunities to change your revenue stream of your business, you need to understand that probably only 20% of it is going to work. So that's why you need to have an environment that's very agile, that you can get to speed to value very, very, very quickly without making it a project to be able to ingest and use this data. That's essentially it. Just work as a team. If you are, working with IT or not with IT, I've seen it work both ways. Businesses can be completely in control of their own destiny. Very successfully in the alternative data world. Generally speaking, if you're scaling throughout an enterprise, you want to involve your IT department. And the success stories, you've heard these before. All this really says is once you have this environment set up, doing things like taking flight patterns and figuring out who owns these planes and trying to detect whether there's M&A transactions in the works, it becomes kind of a trivial exercise. Right? The hard part is having the framework, building out this framework so that every time you have a new idea, it's not a major project. So you have some inkling that if you can get these flight patterns, you can do some detection. There's evidence here on the Quanda website. There's also evidence that this actually is a thing that works. We actually have done it for clients. Once the framework is built, getting this data in and doing this analytics really was not the hard part. The hard part was everything upstream to that, right? And I would just say that Caserta, we're just a consultancy. We do strategy, we do architecture, and we do implementation of alternative data solutions. And that's it. Thank you.